Your devices are getting faster, but they are also turning into active volcanoes. Without powerful thermal management, even the strongest chips would fry in seconds. Welcome to today's hardcore breakdown. In this video, we are stepping inside the factory to uncover exactly how a raw block of metal transforms into the ultimate thermal armor for your electronics. We'll explore everything from material choices to the 10 core manufacturing processes that make cooling possible. So, what exactly does a heatsink do? Its job is simple: pull heat away and expand the surface area. It takes the extreme, concentrated heat from a tiny chip and spreads it across a massive array of metal fins. By maximizing the surface area exposed to the air, heat sinks allow natural convection or fans to easily blow the heat away. The foundation of any heat sink is its material, and the industry relies heavily on two heavyweights, aluminum and copper. Aluminum is the all-around champion. It's lightweight, affordable, and easy to shape. Copper, on the other hand, is the thermal monster. It offers nearly double the thermal conductivity. It's heavier and more expensive, but when you are dealing with extreme power density, copper is irreplaceable. Now, how do we shape these metals? Here are the 10 processes driving the industry. Aluminum extrusion. Think of it as industrial toothpaste. It pushes hot metal through a die to create long, continuous fin profiles. It's cost-effective and perfect for mass production. Stamping and zipper/folded fins. A press punches out individual, paper-thin metal fins. These are then folded and locked together like a zipper, creating ultra-dense arrays that maximize surface area. Reflow soldering to assemble those folded fins and heat pipes. They pass through a high-temperature oven. The solder melts, bonding the components together for excellent thermal transfer. Die casting. When you need complex, three-dimensional shapes, like the housing for an EV inverter, liquid metal is forced into a mold under extreme pressure. Swaging uses brute mechanical force to cold press heat pipes tightly into an aluminum base. Metal injection molding is used to create incredibly complex, miniature thermal components with high precision. Skiving. This is incredibly satisfying to watch. A sharp blade literally shaves thin fins up from a solid block. Since there are no joints or solder, there is zero thermal resistance between the base and the fins. Forging. Using hundreds of tons of pressure, metal is smashed into shape. This compresses the grain structure, making highly efficient, dense pin-fin heat sinks. CNC machining, for absolute perfection. CNC mills cut custom mounting holes and machine the bottom plate to a mirror-like finish, eliminating microscopic air gaps for flawless chip contact. But the raw metal isn't ready yet. It needs a final layer of protection, surface finishing. Processes like anodizing and plating prevent oxidation and corrosion, while black anodizing actually boosts the metal's ability to radiate heat. For harsh environments, an epoxy powder coating or painting provides a tough, electrically insulated, and corrosion-resistant shield. If you are developing next-generation electronics and need custom thermal solutions that combine all these cutting-edge processes, KAIAO is your ultimate partner. We provide world-class prototyping and low-volume manufacturing to keep your innovations running cool. Thanks for watching. Don't forget to like, subscribe, and visit KAIAO today to bring your designs to life.